Welcome back. A warm welcome to you. So let's move ahead. In the last video we have seen briefly about the history of coordinate geometry. Then also we have explored, we have two scenarios. We have seen how to find out the x coordinate and y coordinate of a given point in graph sheet. We also seen how to plot a point on graph if we know the x coordinate and y coordinate. Since we know how to plot the x coordinate and y coordinate, we'll go ahead in this video to plot the points and create some lines and find out some interesting observations, and which will enable us to know about slope and also to find an equation for slope. So I request you to pause the video and plot all the points whatever I have given here, that's minus 4 comma 2, minus 1 comma 2, 1 comma 2, 9 comma 2, minus 1 comma 6, 1 comma 6. You can pause the video, you can plot all the points, and when you are back you can see the next activity. So let me go ahead and plot these points. Minus 4 comma 2, minus 1 comma 2, 1 comma 2, this is 1 comma 2, then I have 9 comma 2. Similarly, I have minus 1 comma 6 and I have 1 comma 6. Now let me try to join these points. Let me also join these two points. I am trying to join all the points whatever is visible there. Let me also try to join these 2 points. I'll try to join these 2 points. Okay, let me try to join these 2 points. Okay, I am lucky. I got it. Super. So let's try to attach some alphabet to this coordinates. What this picture resembles like? Resembles like a slide. Okay. Now let's say that there is a monument above this pillar, and this is a tourist spot. People want to visit the monument. They want to go in this direction, visit the monument and get down. Seems interesting. Okay, now you have been asked to create stairs so that they can move in this direction and they can get down in this direction. So let's try to create the stairs. Similarly, the opposite direction, may not be exact, but I'll tell you what I'm trying to do here. Let me put down some alphabets around them. Say that this is equal to O, this is K, this is O, this is K, this is H, this is F, okay. So we have plotted the points and I have given alphabets to them. So you know this is okay to have fun. OKHVFN. Now the picture doesn't seem to be clear. Okay, will be this is only just to plot the points. We will see actually what we want to discuss here. Let's see that you can see that the line ON is parallel to the x-axis. Similarly, the line KF is parallel to the x-axis, and you can observe on the line which is parallel to the x-axis, that is ON, you can see that the y coordinate is always constant. You can see what is H, -1, 2, so y is 2, V 1, 2, that's y is 2, N 9, 2, which is 2. So that gives me that any line parallel to x-axis, y coordinate is constant. Similarly, you can also arrive at any line parallel to y-axis, like you can take KH, or FV. Let us look at K and H. K -1, 6, my x coordinate is -1. F 1, 6, oh sorry, it's K and H. H you can see it's -1, 2, so the x coordinate is same. Similarly, F and V, you can say that x coordinate is 1 and V coordinate is 1. So I can say parallel to y-axis, x coordinate is constant. We'll arrive at the equations in the next video, but just note down this observation. Okay. Now let's come back to our story. The story is that we have a monument. The tourists have to visit this, so they'll be moving in this direction and they will climb up and they will climb down. And after some time, you thought of taking the feedback of the tourists. So the tourists came back and said that it's difficult to climb up, but it's fine to climb down. And they said that they are not comfortable in this direction. So what you did, you switched the paths. You said that you climb up in this direction, that's from N to F, and climb down from K to O. Then after some time, you again requested the feedback. The tourists said they are pretty comfortable now in this particular path, but they said they don't want to move in this direction, they want to go back to the original direction. So, but they said that we want to have the whatever the slantness you have in this direction in the opposite direction too. So what you did, you went back and you saw that why they are feeling not comfortable when they are moving across O2K, and they are very comfortable when they are moving, then climbing up in the direction of NF, N2F. You found that it's the same vertical distance you are arriving in both the ways, but the x distance whatever you are covering is different. That means you are taking less horizontal distance to move across this vertical distance, whereas in the second case you are taking more x distance to cover the vertical distance. So what you thought, let me try to replicate the same thing, and you looked at the coordinates of n. N coordinates are 9 comma 2. So you went back to this direction and you plotted minus 9 comma 2, and you know that it will be the same distance in the opposite direction. Now you joined these two lines. You joined these two lines and you have named this, let me say, yes. Okay. Now the tourists are very happy. They are very comfortable climbing up. Now you can see the difference between the first scenario and the second scenario. That means when you are climbing across OK or when you are climbing across the line SK, the difference, as I said earlier, is the distance between the distance you have taken in the x direction to achieve the y direction. Suppose I have two coordinates x1 comma y1, x2 comma y2, then their horizontal distance covered is given by x2 minus x1, nothing but the difference between the x coordinates of the 2 points. Similarly, the vertical distance is given by the difference between the y coordinates, y2 minus y1. Now you see that this ratio of y2 minus y1 to x2 minus x1 is actually making the line look slant or look steep. So you want to find out the ratio of y2 minus y1 by x2 minus x1 in both these scenarios. The first scenario, you are taking the line OK, the path along OK. You see that the y2 minus y1 is nothing but 6 minus 2, that's nothing but k is 6, O is 2, 6 minus 2 by minus 1 plus 4. That's nothing but 4 by 3. Now you have taken the second case and you have seen what is the value of y2 minus y1 by x2 minus x1. So the second line is SK. So you have to take the ky coordinate and subtract it from the s coordinate. What is s coordinate? S coordinate is minus 9 comma 2. So that is 6 minus 2 divided by minus 1 plus 9. That's nothing but 4 by 8. Now you can see something interesting here. As you are taking more x distance, your slantness is becoming less, This is nothing but called as slope of a line. So the slope of a line is nothing but the difference in the y direction divided by the difference in the x direction, or to be specific, the difference between the y coordinates of 2 points divided by the difference between x coordinates of those 2 points. Now we know that slope is positive here. Now can we come across a scenario where the slope is negative? Let's look at the line Fn. If you look at the line Fn and try to find out the slope according to the equation y2 minus y1 by x2 minus x1, you see that n y coordinate is 2 and f y coordinate is 6. That means 2 minus 6 divided by n y coordinate is 9, x coordinate is 9 and f x coordinate is 1. Nothing but 9 minus 1. That's nothing but minus 4 by 8. This is half. You can see that this is minus half. Wait here. Sk, I see the slope as half, and Fn, I see the slope as minus half. Now why the slope is reducing in this direction? Because to move from V to N positive direction in x-axis, in y-axis I am moving in the negative direction. That means I am going down from F to N. That's why you get a negative slope. So the summary is, the slope is positive whenever you are climbing up, and the slope is negative whenever you are climbing down. The slope is positive whenever you are climbing up, and the slope is negative whenever you are climbing down. This is important. What else we can arrive at? Let us take a line. Let us take line KF. Let's take line KF and see what happens. I am taking the line KF. If you see KF, the y coordinate difference is 6 minus 6 divided by 1 minus of minus 1, that's plus 2, that's nothing but 0. So you know that KF is parallel to x-axis. So this gives us that horizontal line, the slope is 0. And what about vertical line? Vertical line, you will see that the slope is undefined. Let's take this line FV. Y coordinates of V and F are 2 and 6, 2 minus 6. Whereas the difference of x coordinates is 1 minus 1, 0. So something by 0 is undefined. So now you can see what is the definition of slope and how slope changes, and also we have seen that keeping constant y and changing the x, slope reduces. Similarly, keeping the x constant and changing the y, the slope will be increasing. Let me just take a minute and explain that to you before closing this session. Let us say that my first scenario, my x is constant. Second scenario, my y is constant. So my x is constant in all the scenarios. So if you want to join, I can change my y. Now what will happen to the slope? Now what will happen to the slope? Take it as a straight line. You have to pardon me for that. Let's take another one. Now what's happening here? You can see that the steepness is increasing. That means the slope is increasing. Slope is increasing. Whereas, let's say this scenario where the y is constant and your x is varying. You can see here, as x is increasing, slope is decreasing. In this scenario, as y is increasing, slope is increasing. So we know that slope equal to y2 minus y1 by x2 minus x1. If I keep my x as constant, changing the y2 coordinate will make my slope to increase. Similarly, if I keep my y as constant and change the x coordinate, increase it, then you will see that the slope is decreasing. So in this video, we have seen with a small example what is slope, and that the slope is positive when you are climbing up and the slope is negative when you are climbing down. Slope is 0 for any line which is parallel to x-axis, and slope is undefined for any line parallel to y-axis. In the next video, we will see how to create the equations. We should be very clear about the concept of slope, because slope plays very critical role in finding out the equations of straight lines. If you know slope very well, you should be able to resolve any problem in straight lines, because whole equations revolve around slope. See you in the next video. Thank you. Bye-bye.